Here's a lesson. This lesson is on trig identities. Okay, here's what I want y'all to help me with. When you do an identity, you want to show that one side equals the other side, that the two sides equal each other. What would y'all think of to do that? What's something we could do to show that one side equals the other? Could we choose a value for x? If x equals pi over 6, then we have the tan of pi over 6 minus 1 over cosecant of pi over 6. By the way, you don't have to write this part down. This is just for you to kind of get familiar with what we're doing. So I'm just putting a pi over 6 everywhere I saw an x, because we're going to let x equal pi over 6. Okay, think unit circle now. What is the tangent at pi over 6? Y'all help me out. Square root of 3 over 3, right? Okay, so the square root of 3 over 3 minus 1 over, now I need the cosecant of pi over 6. It's easier to think about the sine of pi over 6. Sine of pi over 6 would be that short leg, so that's 1/2. So the cosecant is the reciprocal of that would be 2, correct? Okay, equals, so what's the sine? We just said the sine of pi over 6 is 1/2. 1 minus, what would the cosine of pi over 6 then? Well, if the sine is 1/2, the cosine's got to be square root of 3 over 2. Oops. Okay, so I went around and actually found the value for all of the places, all those trig functions where x is pi over 6. Okay, how are we going to show that one side equals the other? We need to manipulate it. Any ideas? Multiply by square root of 3 over 2. If I multiply by square root of 3 over 2, this will cancel with this. You agree? So I have one. You want to distribute? Let's distribute that 1/2. 1/2 minus the square root of 3 over 4 on that side. What happens over here? What is the square root of 3 times the square root of 3? 3 over 6 minus square root of 3 over 4. Do those equal? Yep, when I reduce that to 1/2 minus the square root of 3 over 4 equals 1/2 minus the square root of 3 over 4. Very good. We showed they were equal. Let me show you a different way. We know they're equal when we plug a value in. I could have plugged any value in and it would make that true. But watch kind of what we'll be doing in class. Watch how this works. Instead of picking a value, I'm going to plug other things in that we know are true, or use a bunch of substitution. For instance, tangent of x, we know tangent equals the y value over the x value, which is like sine over cosine. So tangent of x is really equal to the sine over the cosine. That's an equivalent exchange, right? Minus 1 over cosecant x. That's a reciprocal. If I flip that back over, wouldn't that be the same as the sine of x, right? Equals, so watch, let's leave that one sitting. What we're going to do is we're going to see if we can make this side that we're working with, the left side, actually look like the right side. Well, if I need to subtract fractions, I need to get a common denominator. Obviously, that would be cosine x. If I put it in the bottom, I've got to put it in the top. So we end up with the sine of x over the cosine of x minus sine x cosine x over cosine x. Simple enough? So now that I have a common denominator, sine x minus sine x cosine x over cosine x, correct? Now, notice you have a sine in the numerator in both terms, so I'm going to factor out sine of x as my GCF. So I would get 1 minus cosine x all over cosine x. Guess what? That looks like this. So we showed that one side is equal to the other using trig identities. So our unit is called trig identities, and that's the sort of thing you'll be doing. Here's the deal. There's a whole lot of trig identities. Get this sheet that you picked up in class on Friday. If you didn't pick it up on class on Friday, there will be one on the website you can print out for yourself, or you can just make one for yourself. So the trig identity ratios, what you want to fill in is things like this. The sine of x equals 1 over the cosecant of x. Those are equivalent to each other, right? So if that's equivalent, what can we put for cosine of x? 1 over secant of x, right? Okay. So what could we put for cotangent of x? Let me change it. Let's start with tangent. Tangent of x, wouldn't that be 1 over cotangent? Right? But couldn't it also be sine of x over the cosine of x? Right? Tangent, since it's y over x, and y is sine and cosine is x, tangent can also be sine x over cosine x. Okay, so now let's do cotangent of x, which would be 1 over the tangent of x, or what else could it be? Could be the reciprocal of the one above it, so it would be cosine of x over the sine of x. So all of those are legal substitutions. All of those are equivalent, so you can substitute them out. Okay, now so this one's easy. So the cosecant of x equals 1 over what? Sine of x. And the secant of x equals 1 over the cosine of x. You having this filled in when you come back from to class will be the sign that you've watched the video and you can start your homework in class. Okay, the next thing is Pythagorean identities. Pythagorean identities. And to do that, I have a YouTube video that's going to be helpful.
Hi, welcome to this tutorial on trigonometric identities. I'm going to introduce you to two basic identities that we use in trigonometry to help solve trigonometric equations. Now, if we had a circle with a radius of 1 and our triangle here with sides x and y for some angle theta, theta can change as we move around the circle. We've got the triangle in the first quadrant at the moment. Here it is in the second quadrant and in the third quadrant and finally the fourth quadrant. Each time y represents the vertical displacement and x represents the horizontal displacement. Let's go back to the first quadrant. Now we know that from basic trigonometry, the sine of an angle is defined as the opposite side over the hypotenuse, y being the opposite side and the hypotenuse being 1. So sine theta would equal y divided by 1, the opposite over the hypotenuse. But y divided by 1 is simply y. So what we have got is that y equals sine theta. Similarly, if we do the cosine of theta, or cos theta for short, is defined as the adjacent side over the hypotenuse, x over 1. And it would follow that x must equal cosine theta. And we use these ideas to sketch the graphs of sine theta and cos theta for any value of theta from 0 to 360 degrees and beyond, or even in the negative sense from 0 through to minus 360 degrees and beyond. Now, by Pythagoras' theorem, we know that this side squared plus this side squared always equals the hypotenuse squared. So we know that x squared plus y squared will equal 1. But we know that x is cos theta. So cos theta, if we were to square it, plus y, which is sine theta, if we were to square that, would come to 1. Now we don't tend to write this as cos theta all squared. There's another way that we write it. It's written as cos squared theta. And for this one, it would be sine squared theta. And this comes to 1. Now in fact, this is true for any value of theta. Not only between 0 and 90 degrees, any value of theta you like. So we say that this is not an equation, it's true for all values of theta. So we write this symbol, 3 lines, the identical sign. And try it on your calculator. Put any angle for theta that you like. Say 100 degrees even. Do the cosine of 100 degrees, square it, plus the sine of 100 degrees, square it, you'll get 1. It doesn't matter what angle you use, as long as these angles obviously are the same. So this is one identity that you need to learn. So we'll just highlight this. And the other identity is the fact that if we do the opposite side divided by the adjacent side, that's defined as tan theta. So tan theta is the opposite side, y over x. But we can see that y is sine theta and x is cos theta. So we have this identity that tan theta is identical to sine theta divided by cos theta. And this is true for all values except when cos theta is 0. Okay, well, do try and learn these two identities, and in further tutorials, I'll show you how we can use them.
Okay, so after that video, theta, which we call theta, we know now that, and I say sine squared x plus cosine squared x equals 1 is one of our identities, right? I also want you to do some variations of that. If sorry, I'm going to start with sine. If sine squared x plus cosine squared x equals 1, then what would cosine squared x equal? Well, if I subtract the sine across to this side, cosine squared x would equal 1 minus sine squared x. So that's just another version of the same thing. In the same token, sine squared x would equal 1 minus, think about it, this time we'd take the cosine across. So it's cosine squared x. So let's add those two to our identities chart. So those are cosine squared x equals 1 minus sine squared x, and sine squared x equals 1 minus cosine squared x. Okay, let's do just one more thing. Yet another version. Another version. Let's go again with, you don't have to write this part, you can just watch. But look at this. Let's divide everything by sine squared x. That's legal, right? That's math legal. Okay, what would sine squared x over sine squared x equal? Well, that's something over itself equals 1. Plus, see cosine squared x over sine squared x? Well, cosine over sine, right here, we notice this one right here. Let me back up. Look at this one right here. It says cosine over sine is cotangent. Well, the good thing about these is they also work squared. So let's make a note to self. Can also you can also square each of these, okay? You can also square each of these. So what that means is, for example, the tangent squared of x equals the sine squared x over the cosine squared x. So you can square these as well. So with that in mind, the cosine squared x over sine squared x is the same as the cotangent squared of x. And 1 over sine squared would be the cosecant squared of x. So there's another identity. 1 plus cotangent squared x equals cosecant squared x. 1 plus cotangent squared x equals cosecant squared x. Let's write that down. I'm going to write it here. 1 plus cotangent squared x equals cosecant squared x. Okay? With that in mind, let's think this through. Wouldn't cosecant squared x minus cotangent squared x equal 1? Think about that. Just move the cotangent over with the cosecant. And by that token, which one do we not have? We need to know what cotangent squared x would equal cosecant squared x, what? You think about it. Minus 1, right? So there's some more. Last ones. Look at this. Whoops. Instead of dividing everything by sine, let's divide everything by cosine squared x. So if I divide everything by cosine squared x, and now we have, let's go with this first one here. What is sine squared x over cosine squared x? Well, that's tangent squared x plus something over itself is 1, and 1 over cosine squared x is secant squared x. So there's another identity. Tangent squared x plus 1 equals secant squared x. Tan squared x plus 1 equals secant squared x. I'm going to put that one here. Tan squared x plus 1 equals secant squared of x. So that version would get me secant squared x minus the tangent squared of x equals 1. Did we do that right? Yep. Secant squared x minus tangent squared x equals 1. And I think we can use tan squared x equals secant squared x minus 1. So those are all identities, and we're going to start using all of those identities to actually solve what we call trig identities. So that's the end of this video, and the next video will be actually to help you do your homework, the trigonometric identity equations worksheet.